maybe two. But at least one of your essay choices is going to be drawing a couple of the mechanisms that we're going over today. Not the stuff before I was like, look at this tricarbonate, whatever, TCA cycle thing. Not that. That's super detailed. This, where you're moving a molecule, you're changing this side chain, you're taking off a methyl group, and then we're ending. Because we're doing a very specific biochemical thing here. And I want you guys to internalize these particular ones because it's indicative of how we do other things. Okay, so, and I'm going to draw it exactly as the board has it, even though this may not be the way that I would write it out myself. You don't have to write it out this way, but then we're consistent. Okay? Look at that nice methyl group over there. Okay? Methyl group. Okay, so now we're going to draw an arrow. And then we're going to draw a blob. You can draw the whole thing out, but it's going to take a long time to memorize it. That your time might better be spent somewhere else. Alright? So, look, we still have our methyl group down here, but we've attached our sulfur to our blob. Sorry. Okay, before we get lost in this molecule, all we're looking at is methionine. Here's our amino side, right, and our carboxylic acid side, right? That's an amino acid. This first part is all just amino acid. This is our R chain. We've taken the sulfur that's in our R chain and attached it to our blob. That's the only difference. All right? That's why there's a charge, because there was no charge here, but there is a charge here because we've added a bond, but we didn't take any away. So we're going back to Gen Chem. Is this balanced or not? Sulfur, it's like oxygen, right? It usually wants 2, but it's flexible. But when it has 3, you've added 1, so you have a plus. So going from here to here, the only difference is, now you can keep it this way if you sideways, I'm just doing it the way the book does it. You've attached your blob to your sulfur, and you've added a charge because sulfur now has 3 bonds. The point of this whole reaction is that we need this methyl group. This is how we're going to get it. You have to keep sulfur. Sulfur doesn't want 1. It's okay temporarily with 3, but this is not terribly stable. But if we have 3, what can we do in the next step? We can take 1 away, right? And then sulfur's still left with 2. So let's do the next step, okay? So